simplest method, which is Euler's method, and this is, as I said, both are one-step method, and this is the simplest one. So that's why it has very low accuracy also, because we'll see how accurate or what is the error in this method, and then we will eventually discuss this more advanced method or widely used method. This is Runge-Kutta method. So for this Euler's method, let's start discussing what is exactly this method is. So in Euler's method, this method actually, this Runge-Kutta method is also based on Euler's method, but with some modification. Some advancement will be there. So over this method, so the base of this method is also the same like Euler's method, but there is some modification. With that we will understand what are the modification and how that helps to increase the accuracy. Right. So far we are not going to discuss this. So later we will discussing that. So first is the Euler's method. So in Euler's method, Euler's method. So to get the derivative, so what we can do is that, um, so before that, in all this method, you have to have some initial conditions. So that's why these are all initial value problems. So all these problems what we will be solving are the initial value problems. These are also called initial value problem. That means some initial conditions will be there. Initial value problem of ordinary differential equation. Ordinary differential equation. Like you have, let's say y is equal to y prime x is equal to f x y. This is given. Now here, what so this is your differential equation, first order differential equation, and now this is given. So at x is equal to x0, you know the value of your y is y0, right? And so this is given. So this is the initial condition which is given, and with this initial condition you will build up the derivative, or you will solve this differential equation for a unknown point or a desired point, right? So this is the basic structure what we are going to solve. Y prime x is equal to fxy and y x0 is equal to y0. So these are given. So now to solve this differential equation, we will expand our y is equal to yx, means y is equal to x, this sorry, y of x. So y is a function of x, so that we will write is so we expand. So for that we expand yx, because y is a function of, so here our variable is x and the independent variable, and this is the dependent function yx about a point x is equal to x0, right? So we can write that Taylor series. So we expand yx our so we expand in Taylor series. In Taylor series. This is Taylor series. तो yx दिस फंक्शन को हमें टेलर सीरीज में एक्सपांड करना है अबाउट x इज इक्वल टू x0. सो देन दिस इज yx इज इक्वल टू yx0 प्लस दिस इज द टेलर सीरीज x0 y prime x0 प्लस x minus x0 का होल स्क्वायर y double prime x0 divided by factorial 2, and in this way it will be expanded. So now if we consider the two terms only, the simplest approximation of this Taylor series, these two terms we will consider. So first assumption is that our approximation is that consider first two terms. So this is the simplest approximation. पहले भी हमने देखा है, right? yx0 plus this is yx0 plus x minus x0 into y prime x0, right? And this rest we are not considering. So now if we remove this part, and as I said, our problem will be like this. So our differential equation is y prime x is equal to fxy. So this is a function of xy, y prime, the first derivative of our function. So and yx0 is equal to y0, right? So now y prime x0 is nothing but f x0 y0, right? So this is the thing. So now so when you consider this from this expression, what we can write is that yx is equal to y x0 plus x minus x0 into f x0 y0. So now this is the in general expression. So now x0 is given. So this is given. So now I want to find the value of my y, that is the solution of this differential equation. So let's say at x is equal to x1. So at this point, so this is my working equation, right? Let's say this is my one equation. So if I put it here, then what will happen? So y x1 is equal to y x0 plus this is x1 minus x0, and this is f x0 y0. So at y is equal to x1, you can find this value if you know this value and this difference and this value, right? So now this is given because this is the initial condition, and this actually we can decide the steps, right? How we are going from x0 to means x1 minus x0. In this step we can actually define, and this also we can calculate from the this uh, here, from here you can calculate from here because this is given, so we just put on there x0 and y0 values, so you will get this f x0 y0 values. So from this given equation, differential equation, we can calculate this. So we'll take an example to understand better way. Okay, so now we'll do some uh, simplification to this formula. That so as I said, we can decide this step. So from x0 to x1, so you have to go from x0 to x1, and that step like x1 minus x0 we can define as h, that how far or how what is the step size you are taking, and that we can say that okay, that is h. So if you add h to x0 which is given, then you will reach at x1, right? So that you can choose which h you want, or how big or how small a step size you want, because um, uh, uh, the criteria to choose uh, h, you will understand when we discuss the error, because that will uh, control your error, this step size. So that will discuss that how error is determined by this h. Anyway, so if I put this in my equation 2, so let's say this is my equation 2. So then what I get is the solution or the value of my function, or this y is this is y0 yx0. I can write yx0 plus this is h f x0 y0. So now if I say x is equal to, so let's say I want to go to the another point which is above this x1, that means x2. So I want to go from x1 to x2, right? Because as I said, so these are all ladders you have to uh, use. So from x0, x1, x2. So you see that if you want to find the value of x1, you need information at x0. So this is the values of x0 values, right? So now if you want to find the value of x2, then you need the values of x1, right? Based on x1, you can calculate x2. So in this way, you can calculate y x2 is equal to, this is y x1 plus h x1 y1. So this is the value of next step. right? So this is the value of your next point. So now in general what I can write is that, so the general equation what I can write is that from all these steps, from this discussion, what I can write that 1, so let's say this I name it as a x I plus 1 is nothing but x yi plus h f xi yi. So this is the general formula to be used in this calculations, and this formula is known as Euler's formula. So this method actually, to go from any point to the next point, or uh, if some other point if you want to find, so always you have to do it in a recursively, that means in a stepwise manner. For example, let's say, so this example, let's we take an example, then it will be more clear. Let's say given dy dx is equal to 3x square plus 1, and y 1 is given is equal to 2. So this is the initial value which is given, or initial condition which is given. So now question is estimate y at 2 using Euler's method. With h is equal to 0.5. Let's say this h is given, right? So now, so this is the, so now how to solve this? So h is given, right? Now you know at x is equal to 1, which is the, what is the value of your y. So this is the step size. So using this step, you have to reach at y is equal to 2, right? So you have to start from 1. So your steps will be like this. So this is x is equal to 1, which is given. This is this value. So this is your x is equal to 2, 1, and then the step size is 0.5. That means your next step will be x is equal to 1.5, and then your next step will be x is equal to 2, because these steps are of 0.5 and this value you want, right? Because this is given, this is known, right? This is y is equal to 2, you know, and this value you want to find at x is equal to 2. In between each step 1.5 you have to take. Okay, so now how to find this? So we will use this formula, right? Y I plus 1 is equal to yi plus h into f xi yi. So now, so at x is equal to 0, or the initial values. of your or given initial values. What is that? So you know age is equal to 0.5, which is already given in the question, and y1, this is also given, sorry, this is 2, and how much I will get this one, x0 y0. So this is nothing but what, f of यहाँ पे क्या लिखना चाहिए हमें,
x1 y1
x1 नहीं, दिस इज f0 y0. तो f0 क्या है, और what I am asking, what is your value of x0 and what is the value of x y0, और सीधा इसका वैल्यू कितना होगा, f x0 y0 इसका वैल्यू कितना होगा, क्योंकि आपको x0 का वैल्यू पता है, राइट. x0 का वैल्यू कितना है, what is x0 in this calculation or in this example, not the calculation, in this example, what is x0, anyone, x0 का वैल्यू कितना है,
सर 1
कितना, इसने कुछ बोला, कितना, हेलो, कितना है x0 का वैल्यू इस एग्जांपल में, 0 means which is known actually, which value or which point is known or given in this example. So what, so which value of x is given,
सर 1 सर
1
होगा 1 क्यों होगा?
exactly 1 is given, right, 1, and corresponding y0 का वैल्यू कितना है, वो भी given है,
2
2 सर
2, right. Now you find out f x0 y0, f x0 क्या है, और ये f xy फंक्शन क्या है, ये जो एग्जांपल है इसमें f xy जो फंक्शन है वो क्या है, if I write it here, f of xy क्या है इसमें, इस एग्जांपल में,
सर 3x क्यूब बाई 3
x
3x बाई
x x स्क्वायर है एक्चुअली, क्यूब नहीं है ये, x स्क्वायर है प्लस 1,
तो सर ये
थ्री
तो
एक्स
आपको
स्क्वायर प्लस 1,
सर ये तो स्लोप
क्या,
की बना है टी वाई ऑफ डी एक्स, ये स्लोप है ना सर?
हाँ स्लोप है एग्जैक्टली. सो 3x स्क्वायर प्लस 1, राइट, f x y जो है. सो नाउ फाइंड आउट दिस वैल्यू, व्हाट इज f0 y0, इसका वैल्यू कितना है, 3 into
4
1
4
square plus 1, right, so this is 4. So now आपको तो इनिशियल सारे वैल्यू पता चल गए, राइट. नाउ विल पुट दिस इन दिस इक्वेशन, सो उसको मैं रख रहा हूँ, now we'll write it here, that then y1 y1 का वैल्यू कितना होगा, y0 प्लस h into f x0 y0. So that means what is, this is 2, right, x0 का वैल्यू 2 दिया हुआ है, h is 0.5 and this is 4. अभी हमने कैलकुलेट किया f x0 y0, that means
4 आ
this will
जाएगा
become
सर.
2 4 हो जाएगा, राइट, 2 plus 2 4 हो जाएगा. So this is 4. So this is y1, that means y of how much it is, this is 1.5, right, right, this is 1.5, this is y1, this is y0 जो हमने कैलकुलेट नहीं किया क्योंकि वो तो गिवन है. तो दिस इज y1 एंड दिस इज y2, अगर इस इक्वेशन से हिसाब से चले. So this is y1, y1 is nothing but y 1.5. So now what is y2, that is y at x is equal to 2. This is how much? y1 plus h f of x1 y1. अब y0 x0 का वैल्यू तो पता है, f x0 y0, इसका वैल्यू कितना होगा?
6 है सर।
y1 दिस इज 6. सो नाउ y1 का वैल्यू आपको मिल गया था 4 प्लस this is 0.5 into 6. How much this is coming? 6 आ रहा है शायद,
7
नहीं
सर आएगा, 7 आएगा सर।
कुछ तो गड़बड़ कर दिया हम लोगों ने. ये 6 कैसे मिला? ये 6 कैसे हो गया?
सर वो नहीं 6 आ रहा, ये आ रहा था 6 वो तो सर।
ये 6 आ रहा है क्या? ये क्या बस आपने क्या लिया इसका वैल्यू? 3 x का वैल्यू कितना होगा? एक्स स्क्वायर है ना, तो x का वैल्यू कितना होगा इसके लिए? x1 कितना है?
सर 1.5।
1.5 है ना, उसका स्क्वायर होगा प्लस 1. ये कितना आएगा? ये आएगा 3.25 राइट? नहीं,
नो सर 7.75।
7.75 आ रहा है सर।
7.75. ओके, तो दिस इज विल बी 7.75. ठीक है, तो ये 6 नहीं है, इसने भी बोला, तो ये 7.75 आ रहा है. तो देन टोटल कितना आएगा? इसका आधा होगा, फिर 4 इससे जुड़ेगा, तो हाउ मच इट विल कम ऐड करने के बाद? ये 7.75 राइट?
सर 7.875 आ रहा है सर।
हाँ ठीक है, 7.75 गलत लिख रखा है, 7.75. यस. हाँ कितना आ रहा है? 7.875 राइट? हाँ ठीक है, 7.875. सो दिस इज योर y2 जो एक्चुअली पूछा गया था एग्जाम, जहाँ पे आपको चाहिए. So see, as we are discussing that if you want to go at some point, you have to use different steps. Instead of h, the step could have been asked as okay, use h is equal to 0.25. तो अगर 0.25 होता, कितने स्टेप लेना पड़ता? How many steps we should take if the step size is 0.25? तो कितना वैल्यू यहाँ से निकालना पड़ता, कितने y तक जाना पड़ता? ये तो y2 तक गए आप, राइट? इफ इट इज, if h is equal to 0.25, then what will be the y? यहाँ पे क्या होगा? y का, i का वैल्यू कितना होगा? कितने स्टेप लेना पड़ेगा? इतना डिफिकल्ट लग रहा है? ये तो सिंपल मैथमेटिक्स है. आपको 1 से 2 पे जाना है, स्टेप है 0.25. बताओ.
4 स्टेप सर।
4 स्टेप लेना पड़ेगा. सो यू हैव टू फाइंड y4 और so you have to go to y4. That means let's draw it here. maybe here freshly we can draw here. So this is, let's say, x is equal to 1 because that is the starting is given, and then x is equal to 1.25, right, and then 1.5, then 1.75, then 2, right? So this is y0, y1, y2, y3, y4, राइट। अगर कोई फॉलो नहीं कर पाया तो उनके लिए ये है, ठीक है। सो दिस इज द स्टेप्स यू हैव टू टेक, दैट मीन्स हाउ स्मॉल यू आर टेकिंग द एज, you have to take larger step size, or steps to calculate the desired value. And now we will discuss that how the error depends upon age. आपको क्यों एज छोटा लेना चाहिए, छोटे से छोटे एज क्यों चाहिए। बट एक चीज आपको ध्यान देना पड़ेगा, इफ यू आर गोइंग फॉर ए स्मॉल एज देन योर कैलकुलेशन और कंप्यूटेशनल टाइम इज गोइंग टू इंक्रीज, राइट। अब इतना जितना छोटा एज लोगे आपको उतना सारे स्टेप्स फॉलो करना है, और जितने स्टेप्स फॉलो करोगे दैट मच टाइम यू हैव टू स्पेंड टू कैलकुलेट, राइट। So that is the problem. So now you should know the error, how much you are getting error, or your perform means in your calculation how much error is there due to this calculation, or this is approximate method, this in this Euler's method. So can anyone tell me that what kind of error we can expect from this this method, or what would be the name of the error, or which error we should look into? There are many errors, right? 2-3 errors we have discussed. So यहाँ पे कौन सा error हमें आएगा, और there is a possibility to encounter that error, क्योंकि हमने कुछ अप्रोक्सीमेशन लिया है, उस अप्रोक्सीमेशन से इस एरर के बारे में आपको पता चल जाएगा। हमने कौन सा अप्रोक्सीमेशन लिया था, टेलर सीरीज को हमने टर्मिनेट कर दिया, राइट। वी डिड नॉट टेक द एंटायर टेलर सीरीज, दैट मींस वी ट्रंकेट द टेलर सीरीज एट सर्टेन पॉइंट or after some terms. That means there is a possibility of truncation error. Mostly in this method, whatever we are discussing, truncation is the one of the major error, right? So in this case, what is the truncation error, or how much truncation error we are doing? The major cause of loss of accuracy is the truncation error. So in this method, the major cause of loss of accuracy is truncation error, TRUN, truncation, because we are truncating the Taylor series, right? Now यहाँ पे कुछ चीजें ध्यान देने वाला है कि see, this process is a stepwise process, right? So you from one step to another step to another step to another step. In this way, you are just going up. So it's a kind of ladder. You are stepping up into a ladder, right? सीढ़ी से हम जैसे चढ़ते हैं ऐसे वाला, एक से दूसरे दूसरे तीसरे ऐसे करके हम चढ़ते जा रहे हैं, और वी आर रीचिंग आउट आवर डिजायर्ड, और जो हमें चाहिए, जो पॉइंट चाहिए वहां पे पहुंच रहे हैं। सो नाउ ईच स्टेप्स यू आर डूइंग द ट्रंकेशन, राइट, क्योंकि हर स्टेप में हर पॉइंट पे आपको फुल टेलर सीरीज लेना चाहिए था, बट वी आर नॉट considering the entire Taylor series. So each step we are making truncation error, right? Truncation error. So each step we are doing a truncation error. So that means this truncation error will be propagated to the other steps, right? So whatever mistakes you are doing here, that is also you are actually making more mistakes here and that more and then more, something like that. Because आपने y1 का वैल्यू गलत निकला, राइट, y0 तो गिवन था, वहां से आपने y1 निकाला, y1 ट्रंकेशन करके निकाला, दैट मीन्स y1 का जो वैल्यू है दैट इज गलत वैल्यू है, वो तो एक है ही, ऊपर से आपने वो सीरीज भी पूरा नहीं लिया, राइट. सो ईच स्टेप यू आर हैविंग टू काइंड ऑफ errors. One is the error which is propagating from the previous steps, and one is your this this truncation, or due to the truncation of the Taylor series. So the local truncation error is, so in step, so what is the, so that is called, there are two types of, one is local truncation error, another one is a global truncation error. Global truncation error. So local means in each steps you are doing that, each step you have this truncation, or one is global. Global means local plus propagated, right? So this is actually the sum of local plus propagated. This is local, that means due to truncation, and propagated, that is because of previous value you have calculated wrong. So that is also now propagated to the next step. So now first we will estimate this local truncation error, and then we will see what is the total error or the global error or final error in this calculation. Okay, so we can do it here. So this is truncation error. So the truncation error at any step, let's say that is I plus 1. So what is that? We are, so before that, what I can write is that in general y plus 1 जो फॉर्मूला है उसका हमारा ऑयलर्स मेथड का, वो ऐसा होना चाहिए, yi plus yi prime h, this is first derivative, plus yi double prime into h square by 2 factorial plus और भी टर्म्स है, बट हम यहाँ तक लेते हैं. So this is the error, truncation error, right? So we have to add the terms beyond this value, right? That means our error, truncation error at this step, I plus 1 step is, this is because of these terms, right? yi double prime h square by 2 factorial plus y triple prime I h cube by 3 factorial and all other terms. So this is the truncation error. Now for a small h, we can approximate this also. This truncation error को हम approximate कर सकते हैं I plus 1 as, क्योंकि हम पूरा तो सीरीज ले नहीं सकते, तो हम इसको डबल प्राइम h स्क्वायर बाई 2 यहाँ तक ही लेंगे. That means y double prime by 2, this is a constant. That means this truncation error, this is the local truncation error, this is proportional to your h square. ये हम पहले भी देख चुके हैं, right? This kind of relationship, that how the truncation error depends upon my h value or the step size. So this is the relation between truncation error and the h. That means if you have small h, then you have a possibility of less error in your calculation. So let's say I have, or in a calculation, n steps has been taken, because this error will be propagated right to the next step, and this all the errors will be summed up to get the uh, final error. So so now let's say if the final estimation required 10 steps. लेट्स से आपको आपने जो कैलकुलेशन किया उसके लिए आपको 10 स्टेप्स लेना पड़ेगा. So the total global truncation error, because that is now adding up all the truncation error. So total or global truncation error at target point x is equal to b. लेट्स से b कोई भी एक अननोन पॉइंट है जहां पे आपको निकालना है x is equal to b. तो हम यहाँ पे हमेशा मॉड्यूलस निकालेंगे. तो t2 tg means global is equal to, you have to add all these errors 1 n ci h square. Ci is the, let's say, this approximate constant. Once this y double prime इसका वैल्यू होगा different पॉइंट पे different, right? Because this y prime xi yi, right, or xi, so to say, in this case. Okay, so now if I write down this, then this will be c1 square plus c2 h square, ऐसा करके cn h square, all this constant coefficient will become because of this second derivative divided by 2. So now let's say we can have some average value of, let's say, c, or all these uh, values we can write like some average coefficient or average value of, let's say, your derivative. So what we can write, that let's say c is equal to, this is average value cn divided by n. If this is the case, then truncation error is equal to n c h square. Now you know that x is equal to b is the target point. So if I want to write my h in terms of x and y and n, then how I can write? So what will be your n? N is nothing but sorry, b minus x0 divided by h, if h is given. So you can put it here and you can write, so this is n means b minus x0 divided by h. So that means this is ch, right? So this is the n. I can write b minus h0 divided by h. Yes, h actually was a. So this is the expression for your error. So see, depending on your um, calculation, you have or step size, you have different truncation error. So from this example, whatever we discuss, for that, can you calculate this truncation error? Because h is given, h is 0.5. So actual problem was h is equal to 0.5, right? And other things are also given, right? Y prime is equal to 3x square plus 1, y1 is equal to 2. These all are given, right? So now calculate this truncation values. What is the value of this? So अब ये वैल्यू निकालो, क्या है, कितना है इसका वैल्यू. हेलो, किसी को मिला? ठीक है, आप लोग इसको कैलकुलेट कर लेना. ठीक है, कल मैं पूछूंगा आप लोगों से कि कितना आया था ये एरर है इसका. ठीक है, कल हम इसका आगे का जो मेथड है, रोंगे-कुत्ता मेथड, उसको हम डिस्कस करेंगे. ठीक है
सर.
हाँ, क्या?
सर मुझे एक चीज़ नहीं सर इसे समझ आ रहा है सर इसमें. जैसे ये जो आपने ईलर मेथड और रंग-कट्टा मेथड जो पढ़ाते हैं सर हम लोग,
हम्म.
तो इस मतलब किस टाइप की प्रॉब्लम सॉल्व करने के लिए मतलब हमें कहाँ दिक्कत होता है तो हम यूज करते हैं इन्हें.
कहाँ डिफरेंशियल इक्वेशन सॉल्व करने के लिए तो डिफरेंशियल इक्वेशन जहीं पे भी आएगा वहाँ पे भी आपको ये लगाना पड़ेगा. जहाँ पर ऑर्डिनरी डिफरेंशियल इक्वेशन आपको सॉल्व करना है, आपको अगर कहीं पे भी आप ले लीजिए जहाँ पे आपका डिफरेंशियल इक्वेशन इन्वॉल्व है आपका प्रॉब्लम
यस
में, तो
यस।
वहाँ पे भी आप कर सकते हो इसको यूज।
मतलब सर ज़्यादा डिफिकल्ट डिफरेंशिएशन है तो उस केस में हम यूज कर सकते हैं सर इन्हें।
यस डिफिकल्ट ऑफकोर्स, ज़्यादा डिफिकल्ट नहीं। अगर न्यूमेरिकली करना है, अगर आपको प्रोग्रामिंग लिख के करना है, कंप्यूटर में करना है सॉल्व, तो आपको यही सब मेथड यूज करना पड़ेगा। अगर डिफरेंशियल इक्वेशन अगर सिंपल भी है तब भी आप कंप्यूटर में कैसे करोगे, कुछ मेथड आपको यूज करना पड़ेगा ना।
ओके सर।
मतलब कोई भी बात, मतलब कोई भी डिफरेंशियल इक्वेशन हो, डिफिकल्ट तो कर ही सकते हो, बट अगर सिंपल भी है बट उसको आपको कंप्यूटर में करना है, न्यूमेरिकली करना है, तो आपको ये यूज करना पड़ेगा। ठीक है।
यस सर, ये पूछ रहे थे सर इंटरपोलेशन जो हम सर पढ़ रहे हैं सर,
हम्म।
तो सर उसमें दो चीज़ आता है, कि फॉर इक्वल इंटरवल के लिए, एक फॉर अनइक्वल इंटरवल के लिए।
हमारा इक्वल इंटरवल ही है हमारा।
अच्छा सर, और सर इसमें जो न्यूटन इंटरपोलेशन है सर, उसमें फॉरवर्ड बैकवर्ड दोनों पढ़ना है ना सर इसमें तो।
हाँ फॉरवर्ड बैकवर्ड दोनों, हमने सिर्फ फॉरवर्ड वाला किया था, राइट।
ओके सर।
हम्म। और किसी को कुछ पूछना है? ठीक है, फिर कल हम आगे का ये यूज करेंगे। ठीक है, डिस्कस करेंगे रंगीकुट्टा मेथड का। ठीक है, कल भी इसी टाइम पे करेंगे फिर। ठीक है। ओके ठीक है, चलो फिर। थैंक यू।